Hello, in this video we are discussing frequency warping in a BLT. BLT bilinear transformation technique. Already in the previous video we have discussed this BLT and we have developed some formulas. We know that in case of IR filter designing, all the methods like Butterworth, Chebyshev are analog filter designing and we are interested in digital filter designing. That's why we need a transformation technique like a BLT. After designing analog filter, our transfer function H of S is analog filter transfer function and we need to transfer it to the digital filter transfer function. This time also we need transformation technique like a BLT. Now transformation technique means what? The S plane we need to transfer to the Z plane. That means this J ohm axis we need to transfer to the unit circle and left half of S plane we need to transfer to the inside the unit circle. Then only we can say stable H of S has transferred to the stable H of Z. So in BLT we are transferring this J ohm axis only at once to the complete this unit circle. Now what happens because of this? We know the range of analog frequency. It is minus infinity to infinity and the range of digital frequency is minus pi to pi. That means we have to map this minus infinity to infinity range to the minus pi to pi range. So in BLT, in the previous videos, we have developed two formulas. One, relation between S domain to Z domain. S is equal to 2 by T, 1 minus Z raised to minus 1 divided by 1 plus Z raised to minus 1. And another one is relation between analog frequency and digital frequency. Omega is equal to 2 tan inverse ohm T by 2. This ohm minus infinity to infinity, we are mapping in a digital frequency omega minus pi to pi. Let's see what happens. This relation we can write like this. Ohm is equal to T by 2 tan omega by 2. This relation is non-linear relation. The relation between analog frequency and digital frequency is non-linear. And the range of analog frequency minus infinity to infinity is completely mapped only once into the digital frequency minus pi to pi. That means the frequency compression happens, frequency warping happens. So what is the effect of this frequency warping on a magnitude response? Let's see. This is y-axis is digital frequency omega, x-axis is analog frequency ohm. We know the relation between digital frequency and analog frequency is non-linear. So this is non-linear relation. Now here we will take analog frequency h of s, or we can say h of e raised to j ohm magnitude response mod with respect to analog frequency ohm. And here we will take h of z, or we can say h of e raised to j omega, and here digital frequencies omega. Let's see, these are our analog frequencies. We'll take all the range, lower range, middle range and higher range. Let's see what is the effect, how it is transferred to the digital frequencies using this non-linear relation. So this analog frequencies we are mapping to this non-linear relation and we are getting this omega value. So this complete range 0 to this frequency we have mapped to the digital frequency, and you can say here this lower frequencies get expanded in a digital domain. Now let's take this middle frequency range. We mapped it on a non-linear relation, and in a digital frequency it becomes like compressed. This middle frequency get compressed. Now let's take these higher frequencies. You can say here the higher frequencies are more compressed. So here this large frequency range we are mapping only to the minus pi to pi digital frequency range using this non-linear relation between analog frequency and digital frequency. Due to that, frequency warping happens. That means higher frequencies get compressed. This is the effect of frequency warping on a magnitude response, mod h of s and mod h of z. Now let's see what is its effect on a phase response. Our relation between analog frequency and digital frequency is non-linear. Now let's check analog phase response. Angle of h of s, this is linear. Now let's see how we are mapping this linear phase response using this non-linear relation to the digital frequencies. We'll transfer all the phases to the digital domain, and you can say here this linear phase response get transferred. When it transferred to the digital domain, it becomes non-linear. So effect of frequency warping is higher frequency bands are compressed while transforming to digital domain in case of magnitude response, and linear phase of analog filter becomes non-linear when converted to the digital domain. These are the two effects of frequency warping. So this is called a frequency warping in a BLT. Thank you.